students, a very good morning. So as we were discussing the term 1 sample paper that is issued by the CBSE. So here 34 number of questions students we have discussed. So let's discuss the rest of the questions today, and let's complete our sample paper, and this whole discussion will help you a lot to just prepare yourself for the term 1 examination. So let's see that the 35 numbers question. So question is, three resistors having values R1, R2 and R3 are connected in series to a battery. So suppose R1 carries a current of 2 ampere sorry, R2 has a resistance of 3 ohms, R3 dissipates 6 watt powers. So then the voltage across R3 is what? So here three registers are given, and that three registers have different property that it has given. So let's first make the three registers that are connected in series, and now with the connection they are just connected with a battery also. So suppose they are connected with a battery here. This is now one negative, this is positive. Now this is our resistance R1, this is R2, and this is now R3. So here what is given to us, it is given R1 carries a current of 2 ampere. So as you know, in series combination all the resistors are carrying the same current. So if because that is the series combination, so if all resistors are carrying the same current, it means that just 2 ampere current will all resistor have, R1, R2 and R3 have. So let's write down the R3 have the current that is equal to I is equal to 2 ampere. Now it is given that R3 has power, that power is given 6 watt. Then we have to find out what is the voltage across R3. So as current and power is known, then you know the relationship, power is equal to potential into potential across the resistor into the current. So from here if we will calculate voltage, then voltage will be equal to power upon current, and power has value 6, current has value 2. If you will solve it, then you will find out 3 volt is the answer. So 3 volt is the resistance, 3 volt is the voltage across the resistance R3. So this was very easy question. Let's see now the question number 36. A straight line plot showing the terminal potential difference V of the cell as a function of current I drawn from it. So as this is given now, what will be the graph between a straight line plot graph between the cell, the terminal potential of the cell, and also the function of current, means the potential versus current graph is shown here. So the internal resistance of the cell would be then. So we have to find out what is the internal resistance of the cell. So you know, when I is equal to 0, then that time V is equal to E, where E is EMF. So here you can see now, for I is equal to 0, V is equal to E at 5.6 volt. So it means that the value of E is now, this is 5.6 volt, and here current, if you will see, then the current is given, that is 2. So for 5.6 you can see now the current is at the extreme point, that is 2 ampere. So we have the value of E and I. Now we can find out what will be the value of internal resistance. So internal resistance is the resistance of cell. So as EMF of cell we know, and current in that through the cell we know. So it means E by I, if you will solve, then that will provide you the value of current. So E has value 5.6, I has value 2. If you will divide them, then that you will obtain 2.8 ohms. So the first option is correct here. Let's see the next question. So a 10 meter long wire of uniform cross section and 20 ohm resistance is used in a potentiometer. So a wire is connected in series with a battery of 5 volt along with the external resistance of 480 ohm. So if an unknown EMF is balanced at 6 meter length of the wire, then the unknown value of unknown EMF. So here we have to use the law of potentiometer exactly. So suppose let PQ is the potentiometer bore of the length 10 meter. Yes, then we can write now the value of current that is flowing inside in the potentiometer, that is I is equal to E upon R plus R dash. So here if you will see now, as two of the resistances that are connected in you can say in series, it is given that here they are connected in series, then these two resistance will be added here simply. So here the value of E that is not known actually. Yeah, here this is given 5 volt. So in the figure as it is now 5 volt, and R plus R dash is 480, R is what? R is given to us, that is now 20 ohm. So 20 plus 480, if you will solve that, then this is equal to 500. So here 5 upon 500. So finally I we can calculate. I will have the value that is equal to now 0.01 ampere. Now we can calculate what is the potential across PQ, the wire that we have chosen. What will be the potential? So as it will be equal to I into RPQ. So RPQ is given already in our question, that is 20 ohm is given to us. Then for that 20 ohm we can calculate what will be the potential across PQ. So potential across PQ will be equal to 20 into 0.01. if you will solve, then this is 0.2 volt potential that we will observe here. Clear? So next one here, if this 10 meter potentiometer wire balance 0.2 volt potential, then 1 meter potential wire, this is the potential that is balanced by the 10 meter potentiometer wire. But what will be if potentiometer wire is 1 meter? So for 1 meter wire it will balance 0.2 upon 10 volt potential. So we have to find out what is the potential balanced by the 6 meter long wire. So for the 6 meter it will be 0.2 upon 10 into 6 volt. So just to solve it, so after solution we will find out it is equal to 0.12 volt. So 0.12 volt is the correct option. So let's see here where is our option? Yeah, this is option number 4 is the correct option. So I think this is now got by you. This is a little complicated problem here. Next question, the current sensitivity of a galvanometer increased by 20% and its resistance also increased by the 25%, then voltage sensitivity will be what? So as you know, the current sensitivity is given by Iz dash is equal to Iz plus, or actually current sensitivity we can calculate, but before that, as suppose current sensitivity is increased, it is given already 20%, and current is Iz first, then after the increment of the current, what will be the final current? That will be I dash G, and Iz dash, then Iz dash is equal to Ig plus 20 by 100 into Iz. So now our current will become, if you will solve, 1.2 into Iz. So this is the value of current now. Next one here, the resistance change is given here, then that is also increased by 25%, So 25 into R here, and if you will solve this whole, then the value of resistance is obtained now. This is 1.25 of R. So 1.2 IZ, 1.25 R. Note this somewhere, note down this one. Now we have to find out what will be the V dash Z. So let's find out V dash Z. This is equal to, you know, I dash G upon R. So here it means that it will be equal to now 1.2 IZ. I think something is wrong actually. Let's just solve it. Now this V dash G, this is equal to as I dash G by R. So I dash G, it has value 1.2 Ig, and R has value 1.25 of R. Now you can solve this one, then this is obtained as 120 upon 125. Again let's solve this one. So if you will solve, then you can find out this will be equal to 24 upon 25. So this 24 upon 25 into Vg, because Ig by R, this will be equal to Vg now. So let's just find out the percent change here in the voltage sensitivity. So percent change can be calculated by V dash G minus of Vg divided by Vg upon 100. So change in voltage sensitivity to the original voltage sensitivity into 100. So let's write down the values here. So value is 24 by 25 of Vg minus of Vg divided by Vg into 100. And if you will solve this one, then this is obtained as minus 4%. So it means that the voltage sensitivity will decrease by 4% here in this case. So this is also the question that you have to just solve by the you can say little care. So next question, 3 infinitely long parallel straight conducting current carrying wires A, B and C are kept at equal distances from each other as shown in figure. So the wire C experience the net force F. If net force on wire C when the current in wire A is also reversed will be. So here it is given in our question. You can see A, B, C are 3 wires. A is carrying 2I current, B is carrying I current, C is carrying I current. All are moving in the same direction. Then for this one case it is given that the wire C is experiencing a net force F. So the net force F, if it is experienced, then we can write down, suppose F1 is the force per unit length between A and C. So for A and C, F1 can be calculated by the formula mu 0 upon 4 pi, and you know I1 I2 by R. So I1 I2 2I into again I divided by R. So this is our F1. Now suppose F2 is force per unit length between B and C. So for B and C, F2 can be calculated again by the same formula mu 0 upon 4 pi, and I1 I2 here I square we will have upon R. So we can now see F1 plus F2 as net force on this wire C, because on wire C the force will be due to A and force will be due to B. So due to A and B, F1 and F2 force we have calculated, and this value is obtained as mu 0 upon 4 pi, and value is obtained finally, that is equal to 2I square by R. And this is now I think here 2R should be, because distance is 2R between them. Then that time this value is obtained as this one, because 2 will be cancelled out and finally both values will be same, and if we will add 2 times here will be, and this is now equal to F. So finally F is equal to what this we can have calculated. Now next one, in the figure, if suppose F1 dash is repulsive force between A and C, then that repulsive force will be equal to repulsive force of A and C, that is F1 dash. So this F1 dash can be calculated as mu 0 upon 4 pi 2I square upon 2R, and this is equal to F2 also. So as F1 is equal to F2, then net force, we can say the net force on C, that is F1 minus of F2, that is equal to 0. So here simple thing is that if we will see what is the net force experience when the current is now reverse. So due to the reverse of the current, as we know, the force becomes repulsive that time. So for that repulsive force, the forces will not be added that time, and for the C they will be subtracted. So that will give us the 0 value. Clear, I think. The next question is, in a hydrogen atom, the electron moves in an orbit of radius 0.5 angstrom, making 10 revolutions per second. So the magnetic moment associated with the orbital motion of the electron will be what? So we have seen the Bohr magnetron cases here. So for that one we can use the formula to calculate the value of magnetic moment. So the value of magnetic moment, that you know, m is equal to IA, and you know we can write I, that is EB pi r square. So here with the help of this one we can now E nu actually pi r square we can write, and now we can put all the values that we have, and that all values will help us to just to solve here magnetic moment in which formula, that is E is electronic charge, nu is what? This is frequency of revolution, and then pi r square is the area, because circular orbits are here. So let's write down all the values and solve. Then after solution you will find out the final value is 1.256 into 10 to the power minus 38 ampere meter square. So you can see the second option is correct for us. So only just you have to use the formula and you have to solve it. The next question is an air cooled solenoid with length 30 centimeter, area of cross section 25 centimeters square, and number of turns carries the current is given. So let's write down first of all what are the given. L is given, this is 30 centimeter. Area is given, this is 25 centimeter square. Third one is given, number of turns is given 800. Then current is given, that is 2.5 ampere current is given. Now the current is suddenly switched off in a brief time of 10 power minus 3 second. Then ignoring the variation in magnetic field near the end of the solenoid, the average back EMF induced across the ends of the open switch in the circuit would be. Here this is the topic of the change in flux, sudden change in flux we are doing, and due to change in flux what will be the value of EMF. So first we have to find out what is the initial flux and what is now final flux. So the initial flux, if you we will find out, suppose that is phi 1, so that is equal to NBA, clear, where N is number of turns, B magnetic field in the case of solenoid, and you know in case solenoid the magnetic field is given by mu 0 and I by L. So you can use the formula here and to find out the value of flux here. So if we will use the formula for the flux, then phi 1 can be obtained as directly I am writing the value, just solve that by yourself. This is minus 10 power 3 Weber. Now the final flux, if you will see, as we are ignoring the variation in magnetic field or other things, then phi 2 will be equal to 0. So it means average back EMF, if you will have to calculate, this is d phi by dt, means change of flux in time. So here change of flux will be equal to this value, that value we have written, and time is given 10 power minus 3 second. So you have to solve this one. So if you will solve, then the value is obtained as 16.7574 volt. So the next question here, a sinusoidal voltage of peak value 383 volt and frequency 50 hertz is applied to a series LCR circuit in which R is L and C are given. So then the power dissipated at the resonance condition is what? So as in LCR circuit we have to find out what is the power dissipated. So the power dissipated, you know, that is given by I square R, and here what we have to find out the value of, first of all, I. So value of I is equal to, you know, that is RMS value we need to find out. So that is I0 by root 2, and here I0 you can find out by the peak value as it is given. So it means that V0 upon R into root 2. Now R is given and all the things are given. We can find out what will be the now value of current here. So V0 is 283 volt, R is given 3 ohm, and root 2 its value put, and if we will solve, then current in the circuit is obtained as 66.7 ampere. So as now current we have obtained, then if we will put the value of current and resistance, then we can find out what will be the power. So that is equal to 13.35 kilowatt. So third option is correct now. The next question is a circular loop of radius 0.3 centimeter lies parallel to much bigger circular of radius 20 centimeter. So the center of a small loop is on the axis of the bigger loop. The distance between their centers is 15 centimeter. So if a current of 2 ampere flows through the smaller loop, then the flux linked with the bigger loop is what? So here in this question, if you will see, so the net flux linked with the smaller loop is phi 1 and with the bigger loop is phi 2. So here it is given that the value of radius is given for the second one, that is 20 centimeter, it will be 2.2 meter, and for the first one it is 0.3 centimeter, means 0.003 meter for the first one. And one more thing is given, the distance between them, suppose x is the distance between them, that is given 15 centimeter. So this is 0.15 meter. Now what we have to do, we have to find out first flux link with the first one, then phi 1, you know, this is given by magnetic field of second into area of first one. So you can find out the value of phi 1 now, and then you can find out the value of m. So m has the value phi 1 upon I2. So here you can find out this value, and similarly you can find out now the value of phi 2. So for phi 2, what we will we have to do, so flux linked with the bigger loop we have to find out. For this one, this will be equal to m into I1. So as current is given already in a smaller loop, current is given, I1 is given, and an m just now I have told you how to find out. So if you will use the formula for m and then you put the value of I1, then that time it is obtained as 9.1 into 10 power minus 11 Weber. So it means our last option will be correct. Next question, if both number of turns and core length of the an inductor is double, keeping the other factor constant, then self inductance will be what? So here in this question, as you know, the self inductance is given by mu 0 n square a upon L. So from here you can see now what will be the L dash if we are using the both number of turns and core of the length, that is double now. So mu 0, if n will be double, then this will be 4n square a and divide by now 2l. So if you will solve this one, 2 here 2 we will obtain, so means 2 times our self inductance will be now. So here it will be doubled simply. The question number 45, if you will see, so given below the two statements labeled as assertion and reason. Now the questions we are moving that are for the assertion reasoning. So let's just see question first. Assertion is given, to increase the range of an ammeter we must connect a suitable high resistance in series to it. The emitter with reason is given. The emitter with increased range should have high resistance. So first let's see which one option is correct for this one. So as you know, to increase the range, uh, uh, first we have to just use the suitable low resistance in emitter, and that should be connected in parallel. So it means that our both of the option, if you will see assertion, so that is also wrong, because to make emitter, we are using low resistance and we are connecting in parallel, and here also this should be the low resistance. So it means that our assertion and reason both are wrong, so that lies in the category 4. So it means that A is false and R is also false. So fourth option will be correct. Now let's see the second one here. The assertion is given: an electron has a high potential energy when it is at the location associated with a more negative value of potential, and a low potential of energy when it is at a location associated with a more positive potential. Reason is given: electrons move from a region of higher potential to the region of now lower potential. So if you will see in this case, the statement, if you will see, means the assertion, if you will see, then this assertion is right. Exactly, electron has high potential energy whenever at any location whenever the more negative value of potential is there, and for the more positive it will have low potential energy, because in potential energy we have negative sign. But electrons movement, if you will see, they move from the region of low potential to high potential, not high to low potential. So the reason is our wrong, assertion is correct. So it means that the third option will be correct here. Now let's see the question number 47. So the question 47 is a magnetic needle free to rotate in a vertical plane orient itself vertical at the poles of the earth here. Now reason is given: at the poles of the earth the horizontal component of Earth's magnetic field will be 0. So here in this case, yes, statement, our assertion and reason both are true, and as at poles magnetic needle orient itself vertically, because horizontal component of earth field is 0 there. So this is the correct reason, means and correct explanation also. So first option will be correct here. The last assertion reasoning problem, let's see for 48. This problem is a proton and an electron with the same momenta enter in a magnetic field in the direction at right angle to the lines of the force. So the radius of the path followed by them will be same. So reason is electron has less mass than the proton. So for this question, if you will now see, if a proton and electrons we have, then that time the centripetal force that should be equal to magnetic Lorentz force. So centripetal force is mv square by r, Lorentz force is qvb sine theta. So here theta is 90, so that's why I am writing only this one. So from here the value of r can be calculated. So r is equal to mv divided by qb, or in place of mv we can write momenta p upon qb. Now what we have to just see the assertion again. In assertion it is given: if proton and electron both are moving with same momenta enters in a magnetic field, means B is already constant, P is constant, then the radius of the path followed by them will be same. So yes, this will be same because charge on both are same. So from this equation you can see all three quantities will be conserved. It means that simple that will be now same here. So it means now if we will see the reason. So the reason is electron has less mass than proton. Yeah, that is correct, but this is not the reason or explanation of first one. So both are correct, but B is not, R is not the explanation of A here. So one more question is here given, that is On increasing the current sensitivity of a galvanometer by increasing the number of turns may not necessarily increase its voltage sensitivity. So, and the reason is given, the resistance of the coil of galvanometer increases on increasing the number of turns here. So yes, as Vc is given by Ic divided by R here. So in this case, when we increase current sensitivity but increasing number of turns, resistance also increases. So it means so current sensitivity does not necessarily implies that voltage sensitivity will also increase. So here in this case, it means that our assertion and reason both are true, and B is R is the correct explanation of A also. So students, by discussing these all questions, now let's just see the section C, and that section C is related to here some of the problems, that is of multiple choice problems, and some question you can say cases are given to us. So in these cases you can now study by yourself and you can solve here. And one of the case study problem is here, it is given for us. So that case study problem is given for the transmission lines. So for transmission lines, as these are the questions, so I'm just not going to just discuss these one here. You can just solve them now. And with the this one, we are going to just end our class here and end our this discussion on the sample paper here. So just let's end it here. In next class we will just start our revisions on different chapters that is going to be in your just RT examination. So just end our class here. Thank you.